VHDL tutorial. VHDL tutorial provides basic and advanced concepts of VHDL. Our VHDL tutorial is designed for beginners and professionals. What is HDL? HDL stands for Hardware Description Language. It is a programming language that is used to describe, simulate, and create hardware like digital circuits, ICs. HDL is mainly used to discover the faults in the design before implementing it in the hardware. The main advantage of HDLs is that it provides flexible modeling capabilities and can express the large complex designs, 107 gates. Today, there are many HDLs available in the market, but VHDL and Verilog are the most popular HDLs. What is VHDL? VHDL stands for Very High Speed Integration Circuit HDL, Hardware Description Language. It is an IEEE, Institute of Electrical and Electronics Engineers, standard hardware description language that is used to describe and simulate the behavior of complex digital circuits. The most popular examples of VHDL are odd parity generator, pulse generator, priority encoder, behavioral model for 16 words, 8-bit RAM, etc. VHDL supports the following features. Design methodologies and their features. Sequential and concurrent activities. Design exchange. Standardization. Documentation. Readability. Large-scale design. A wide range of descriptive capability. What is Verilog? Verilog is also a HDL, hardware description languages, for describing electronic circuits and systems. It is used in both hardware simulation and synthesis. The most popular examples of Verilog are network switch, a microprocessor, a memory, a simple flip-flop, etc. Difference between VHDL and Verilog. VHDL. Verilog. It allows the user to define data types. It does not allow the user to define data types. It supports the multidimensional array. It does not support the multidimensional array. It allows concurrent procedure calls. It does not allow concurrent calls. A mod operator is present. A mod operator is not present. Unary reduction operator is not present. Unary reduction operator is present. It is more difficult to learn. It is easy to learn. History of VHDL. VHDL was developed by the Department of Defense, DoD, in 1980. 1980, the Department of Defense wanted to make circuit design self-documenting. 1983, the development of VHDL began with a joint effort by IBM, Intermetrics, and Texas Instruments. 1985, VHDL version 7.2, the final version of the language under the government contract, was released. 1987, DoD permitted for commercial purpose, and VHDL became IEEE standard 1076 to 1987. 1993, VHDL was restandardized to enhance the language. 1996, a VHDL package used with synthesis tools and became a part of the IEEE 1076 standard. 1999, Analog Mixed Signal Extension, VHDL MS. 2008 IEEE Standard 1076 to 2008 New Features was released. Why VHDL? VHDL is used for the following purposes. For describing hardware. As a modeling language. For a simulation of hardware. For early performance estimation of system architecture. For the synthesis of hardware. Advantages of VHDL. A list of advantages of VHDL is given below. It supports various design methodologies like top-down approach and bottom-up approach. It provides a flexible design language. It allows better design management. It allows detailed implementations. It supports a multi-level abstraction. It provides tight coupling to lower levels of design. It supports all CAD tools. It strongly supports code reusability and code sharing. Disadvantages of VHDL. A list of disadvantages of VHDL is given below. It requires specific knowledge of the structure and syntax of the language. It is more difficult to visualize and troubleshoot a design. Some VHDL programs cannot be synthesized. VHDL is more difficult to learn. Basic elements of VHDL. There are the following three basic elements of VHDL. 1. Entity. The entity is used to specify the input and output ports of the circuit. An entity usually has one or more ports that can be inputs, in outputs, out, input outputs, in out, or buffer. An entity may also include a set of generic values that are used to declare properties of the circuit. Entity declaration. You can declare an entity using the following syntax. Simplified syntax. Entity underscore name is ort underscore one underscore name mode data underscore type ort underscore two underscore name mode data underscore type and example. Using generic. If an entity is generic, then it must be declared before the ports. Generic does not have a mode, so it can only pass information into the entity. Syntax. Entity underscore name is generic. Generic underscore one underscore name data underscore type. Generic underscore two underscore name data underscore type. Generic underscore n underscore name data underscore type. Port. Port underscore one underscore name mode data underscore type. Port underscore two underscore name mode data underscore type. Port underscore n underscore name mode data underscore type. And entity underscore name. Example. Entity logic underscore gates is generic delay time is equal to 10 ns. Port. Input 1 in std underscore logic. Input 2 in std_logic. Output out std_logic. And logic_gates. Rules for writing port name. Port name consists of letters, digits, and underscores. It always begins with a letter. Port name is case insensitive. Modes of port. In input port out output port in out bidirectional port buffer buffered output port. 2. Architecture. Architecture is the actual description of the design, which is used to describe how the circuit operates. It can contain both concurrent and sequential statements. Architecture declaration. An architecture can be declared using the following syntax. Example. 3. Configuration. A configuration defines how the design hierarchy is linked together. It is also used to associate architecture with an entity. Configuration declaration. Configuration _name of entity _name is. Configuration declarations. For architecture _name. For instance _label, component _name. Use entity library _name dot entity _name, architecture _name. And for. And example. Configuration demo _config of even _detector test benches. For TB _RG. For UUT even detector. Use entity work dot even detector SOP RG. And for. And for. And demo config. Types of modeling styles in VHDL. There are 4 types of modeling styles in VHDL. 1. Data flow modeling, design equations. Data flow modeling can be described based on the Boolean expression. It shows how the data flows from input to output. It works on concurrent execution. 2. Behavioral modeling explains behavior. Behavioral modeling is used to execute statements sequentially. It shows that how the system performs according to the current statement. Behavioral modeling may contain process statements, sequential statements, signal assignment statements, and wait statements. 3. Structural modeling, connection of submodules. Structural modeling is used to specify the functionality and structure of the circuit. Structural modeling contains signal declarations, component instances, and port maps in component instance. VHDL objects. VHDL uses the following 3 types of objects. 1. Constants. Constant is an object which can only hold a single value that cannot be changed during the whole code. Example, constant number of bytes integer is equal to 8. 2. Variables. A variable also holds a single value of a given type. The value of the variable may be changed during the simulation by using variable assignment operator. Variables are used in the processes and subprograms. Variables are assigned by the assignment operator is equal to. Example. Variable index integer is equal to 0. 3. Signals. Signals can be declared in architecture and used anywhere within the architecture. Signals are assigned by the assignment operator happy smiley. Example: signal sig1 std_logic sig1 happy smiley 1. Data types in VHDL. Data types are the abstract representation of stored data. There are the following data types in VHDL. 1. Scalar types. Integer data types are the set of positive and negative whole numbers. Floating point data types are the set of positive and negative numbers that contain a decimal point. Enumeration data type is used to increase the readability of the code. Physical data type describes objects in terms of a base unit, multiples of base unit, and a specified range. 2. Composite types. Arrays are used to hold multiple values of the same types under a single identifier. Records are used to specify one or more elements, and each element has a different name and different type. VHDL operators. VHDL operators are used for constructing the expressions. There are the following types of operators in VHDL. 1. Logical operators. Logical operators are used to control the program flow. When the logical operators combined with signals or variables, then it is used to create combinational logic. VHDL supports the following logical operators: AND, OR, NAND, NOR, XOR, XNOR. NOT. 2. Relational operators. In VHDL, relational operators are used to compare two operands of the same data type, and the received result is always of the Boolean type. VHDL supports the following relational operators: is equal to, is equal to not equal to, less than, greater than, happy smiley less than or equal to, is equal to greater than or equal to. 3. Arithmetic operators. Arithmetic operators are used to perform arithmetic operations. These operators are numeric types, such as integer and real. VHDL uses the following arithmetic operators: plus addition, subtraction, asterisk multiplication, division, and concatenation. Mod modulus, rem remainder, abs absolute value, asterisk exponentiation. 4. Shift operators. In VHDL, shift operator is used to perform the bit manipulation on the data by shifting and rotating the bits of its first operand right or left. VHDL supports the following miscellaneous operators: SLL shift logical left, SRL shift logical right, SALA shift arithmetic left, SARA shift arithmetic right, roll rotate left, roll rotate right. Note: operators are evaluated in order to their precedence, i.e., highest to lowest. Highest. Precedence order.